Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So in today's video, as the title suggested, we will be seeing how to find LCM and HCF of two numbers or three numbers using prime factorization method. So far you might have used division method to solve the HCF or find the HCF and LCM, but in today's video we'll see how to prime factorize those numbers and find the LCM and HCF. So without wasting any more time, let's jump right into the video. But before that, if you're new to my channel, hi, I'm Deepthi. Welcome to my channel. I will focus mainly on fundamentals of mathematics, high school mathematics. I will also sometimes go through the quantitative aptitude that is useful for placements, job interviews, bank exams, etc. I request you to please hit the subscribe button down below if you're interested in my videos. So without wasting any more time, now let's jump right into the video. So as you all know, today we'll be dealing with how to find LCM and HCF of two integers or three integers for that matter using prime factorization method. But before that, I expect you to understand the concept of HCF and LCM. I have in detail explained you the concept of HCF in one of my previous videos, which I will link it up here. But just a quick recap, what is HCF? HCF is nothing but the highest common factor that divides two numbers. It is the highest common factor, that is the highest common divisor that will divide two numbers. For example, if we take 6 and 9, and in order to find the HCF by division method, what we'll say is, if we say 9 is divided by 6, we'll get again 3 2s are and 0. So we can say that the HCF of 6 and 9 is 3. This I have done using the division method. In general, there are two ways to find the HCF or LCM. That is, one is the division method and one is the prime factorization method. So in here, I have explained you how to find the HCF using division method in a brief way. So highest common factor is the common factor that divides these two numbers, the highest common factor that divides these two numbers. Okay, so that is the concept of HCM. We have also seen how Euclid's division algorithm can be used to find the HCF of two numbers, that is A is equal to BQ plus R, and using Euclid's division lemma. I have made an in detailed video along with a lot of examples, and I will link it up here for you to watch. But this is how you can find the HCF of numbers. There are numerous ways to do it, but in today's video, we'll see how to find the HCF using prime factorization method. Now, what is the meaning of LCM? This is something which we haven't touched so far in our channel, but I will make a dedicated video to help you understand what exactly LCM is and how it has come into existence. But LCM is nothing but least common multiple, or you can say that as lowest common multiple. So when you say A and B are two positive integers, then LCM of A and B can be written as, LCM means this is the lowest common multiple that is evenly divisible by A and B. That is, if you say, for example, there are two numbers 6, 9. So using the division method that we already know, you must have been introduced this in your earlier classes. How do we find the LCM of two numbers? This is where you find it. 3 2s are 6, 3 3s are 9. Again, 2 1s are 2. Again, 3 1s are 3. So the LCM of 6 and 9 is 3 into 2 into 3. That is 18. Now, how did we get to this number 18? By applying division method, and you know the process here. But if you observe, LCM means this is the lowest common multiple here. 18 is the lowest common multiple that is divisible by both 6 and 9. That is 6 3s and 6 2s. This is the lowest common multiple that is divisible by both 6 and 9. That is the concept of LCM. HCF means the highest common factor that divides those two numbers. But in here it's quite the opposite. LCM means the lowest common multiple that is divisible by both the numbers 6 and 9. Okay, so this is a brief overview about LCM. Now, keeping this concept in mind, let us try to understand how we can apply prime factorization, or how we can find the LCM and HCF of 2 positive integers or 3 positive integers or n positive integers for that matter, using the concept of prime factorization. Now, for example, I will take 2 numbers 30 and 180. I want you to find the HCF and LCM of 30 and 180. How do you do this? So, and I want you to find the HCF and LCM using prime factorization method. The first step for you to find the HCF and LCM using prime factorization is you need to prime factorize the given positive integers. That is, first you need to prime factorize how many numbers they give you. So in here we have 2 numbers, so we need to prime factorize 30 and 180. So 30 is equal to, how do you prime factorize? 30 is 3 tens are 2 5s are. Right. So what are the prime factors of 30? 3 into 2 into 5? Yes. Now 180. How do you prime factorize 180? 180 is here. 3 60s are, 3 20s are, 2 10s are, 2 5s are. So what are the prime factors of 180 here? 3 square into 2 square into 5. That is nothing but 3 into 3 into 2 into 2 into 5. Right. So what we have done is we have first prime factorized these 2 numbers. So just for your understanding, now this is the actual result. And notice one thing here. What I have done is I have written the same numbers at the base of those numbers in one line. As in, whenever there is 3 here, I have written 3 here. Whenever there is 2 here, I have written 2 here. If there is 5 here, I have written the 5 here. These here, 3 to 5, 3 to 5, we can call them as bases, because they do bear one exponent. That is the reason we are calling these 3 to 5 as bases. So basically we have aligned these bases so that they are opposite to each other for these 2 numbers, and then we have the powers associated with these bases. Right. 1 1. Okay. So this is something you need to keep in mind. Next. So now that we've got the prime factorization of 30 and 180, let's try to find the HCF of 2 numbers. How to find the HCF of 2 numbers? The first thing is you need to identify what are the common factors, that is common numbers, in this case common bases between these 2 numbers. That is, we need to say what are the common factors between these 2 numbers. Okay. Now, since we are finding the HCF, first let's write as the common factors. 3 is a common factor because in both of these numbers we have 3. So, I am writing 3 as the common factor. Then we have 2 also as the common factor, and the next common factor is 5. So 3, 2, 5 are the common factors. Now, post writing the common factors, you need to take the exponents of those common factors. Since we are dealing with HCF here, we need to take the least power of the common factor and write it here. Because that is the highest common factor that divides those two, we need to take the least common factor so that it is divisible by those two numbers. Suppose here, what is the least common factor? We have 1 and 2. We have 1 and 2. What is least here? 1. And 5, we have 1 and 1. So least is nothing but 1. So the HCF of 30 and 180 using prime factorization method can be 3 into 2 into 5. That is 30. You might be wondering, why do we have to take least here when it said highest common factor here? I will prove that to you. 30. So if you divide 30 by 30, it will be divided, right? 180 also, if you divide 180 by 30, it is 6. But if we take highest exponents here, we get what? 6, 3 square here. Suppose if we are taking 2 here and if we are taking 2 here and 1 here, what do we get? We get 3 square is 9 into 4 into 5. That is 180. Can you say that 30 by 180 is it divisible or is it proper? No, you will result in a fraction. This is not a whole number and it is not divisible by 180. 30 is not divisible by 180. Here we are looking for a highest common factor that divides both A and B. In this case 30 and 180. What is that highest common factor? 30. That is the reason why we are taking the exponents that the bases that have the least powers to them, because they will become the highest common factor. If we take the exponents of highest powers, it will rather become the LCM, which we'll just see in a minute. Okay, so this is how you find the HCF of two numbers. Now in the same way, I will try to find the LCM of two numbers. In order to find the LCM of two numbers, what we need to do is, we need to write the common basis. Okay, and exponents should have the highest or greatest powers. In here, what is the greatest power of 3 and 3 square? 2. And for 2, it is also 2. And for 5, it is 1. So, in short, what is the LCM of 30 and 180? We get 3 square into 2 square into 5. That is nothing but 9 into 4 into 5. That is nothing but 180. So LCM of 30 and 180 is 180. What is the definition of LCM? We know that LCM of two numbers, to find the LCM of two numbers, we are ultimately determining that number that can be evenly divisible by these two numbers. That means that number is supposed to be larger or equal to these two numbers, in short, because that number, that n number, should be divisible by these two numbers. So in that case, LCM here is 180. So this is our n here, suppose. And we need to see that whether 180 divided by 30, 180 divided by 180, the remainder is 0 or not. Here 180 is divisible by 30. Yes, we get 36. And 180 is divisible by 180. Yes, we get it as 1. So that means the LCM of 30 and 180 is 180. That is the reason we need to take the highest or the greatest exponents of those bases. Okay, so this is the underlying concept of how you need to find the prime LCF and HCM using prime factorization method. Okay, so keeping this concept in mind, now let's see a few problems. So in here we need to find the HCF and LCM of 90, 144 using prime factorization method. So first, as you know, the first step is to write these two numbers and then factorize them. So the first step is, I will write here that we need to factorize these numbers. So this is the first step. So how do you factorize 90 and 144? We'll go here and we can say 2 45s are, 5 9s are, 3 3s are. So the prime factorization of 90 is 2 into 5 into 3 square. So So let's write this 2 into 5 into 3 square. Next, what is the prime factorization of 144? We'll say 272s are, 236 are, 3 12s are, 3 4s are, 2 2s are. So here we can say the prime factorization of 144 is 2 to the power of 4 into 3 square, right? 69s are 144. So 2 to the power of 4 into 3 square. If you see here, what I have done is, I have aligned the common bases that we spoke about just opposite to each other. Here we don't have any 5, but here we have 3 as the base. So in these two numbers, we have two common bases, that is 2 and 3. Now, the second step is to identify the common bases and then write their powers and corresponding to whatever we have to find. Now let's try to find the LCM. It is easier. What are the common factors here? Let's take only 2 and 3 first. Because we know for a fact 2 is there and 3 is there. Here we are considering the greatest exponent, right? And I have shown you why we are considering the greatest in order to get the least number. Can you say that the power of 5 here is 1? Yes, we didn't have 5 here. But I will tell you a short trick that will help me remember this. Can I consider this as 5 power of 0? Just think about it. You know that a power of 0 is 1. Right? So, we don't have a common basis 5 here. However, if we assume this hypothetical number 5 power of 0, can we say now that these two bases are aligned? Yes, but in theory, we need to get the highest or greatest exponent, right, of a common factor here. So, if we write 5 here, what is the greatest exponent of 5 that you can put it in here? 1. Because out of 0 and 1, we know for a fact that 1 is greater than 0. Now you know the drill. What here we have 2 power of 1 and 4. So 4 is the highest. And here 1 and 0 we wrote 1 and 2 and 2 it's the same. So we can write 2 as is. Right? So the least common multiple of 90, 144 is, the third step is to multiply these numbers. So LCM is 2 to the power of 4 into 3 square into 5. That is equal to 16 into 9 into 5. That is 144 into 5, which is nothing but how much? 20, 22, 720. Okay, so the LCM of these two numbers is 720. That is the lowest number that can be divisible by evenly by both 90 and 144. Okay, so this is how you find the LCMs in prime factorization. Now let's do the HCF. So I'll write the HCF here. How do you find the HCF? Instead of taking the common highest exponent, we'll take the least exponent, right? So in the same table, what I'll do is, I'll extend this to least exponent. Right. Now, here, 2. What is the least exponent of 2? The power here of 2. Common base is 2, 3 and 5 also will consider as the common base here. So, because we assume that hypothetical number 5 power of 0, even though we don't assume or we don't put 5 here, we will get the expected result only as answer. I'll show you how. So, 2 here, what is the least exponent? 1 for 2, right? Because 4 is the highest, 1 is the least. For 3, 2 only because both are equal. For 5, it's 0. And even though if we remove 5 also, it makes sense because 5 power of 0 is anyways 1. So if we consider this 5 as 0 here, because we don't have 5 in the prime factorization of 144, what do we get as HCF? We will multiply these numbers now. So 2 power of 1 into 3 power of 2 into 5 power of 0, or you can consider simply 2 power of 1 into 3 power of 2 because we don't have 5 here. So we will get 2 into 9, that is 18. So the HCF of 90 comma 144 is 18. That is, this is the highest common factor that divides these two numbers. 18 5s are and 18, how many times? 18 8s are. Okay. So this is how you find the LCM and HCF using prime factorization method.